next lecture, we are going to solve some more example of conjugate, modulus and argument of a complex number. Prove that the area of the triangle whose vertices are the point represented by the complex number Z1, Z2, Z3 in the argon plane is summation Z2 minus Z3 modulus of Z1 square by 4i Z1. We have given three complex numbers Z1, Z2, Z3 which are the vertices of the triangle. We have to show that the area of the triangle is given by this expression. Answer. Let Z1 equal to x1 plus I y1, Z2 is equal to x2 plus I y2, Z3 is equal to x3 plus I y3, so that the coordinate x1, y1, x2, y2, x3, y3 are the vertices of the given triangle. So that the coordinate of the vertices of the given triangle are x1, y1, x2, y2 and x3, y3. Now the required area of the triangle is given by area of triangle equal to, by using the formula, area of triangle equal to 1 by 2 x1 whose three coordinates are given. By using the formula indeterminate, we get this one. In the next step, we are going to multiply by I in the second column. In order that value of the determinant will not change, we will multiply the denominator of this number by I. When we multiply the second column by I, in order that value of the determinant will not change, we will multiply it by 1 by I, so that it will be equal to 1 by 2i by x1, x2, x3. Then this is I y1, I y2, I y3. 1, 1. If I take I common from the second column, then this I and this I and that I will be cancel each other, and we will get this. This is the big. Again, by applying the operation x1, x2, x3, applying the operation C2 tends to C2 plus C1, we will get x1 plus I y1, x2 plus I y2, x3 plus I y3. By our assumption, this is z, this is z2, this is z3. So that in the next step it will be my 1 by 2 high modulus determinant of x1, x2, x3, z1, z2, z3. Then 1, 1, 1 determinants. Next step, expanding along the first column, we will get 1 by 2i x1 multiplied with this determinant multiplied with z2 z3 minus x2 z3 z3 minus z1. This is plus if I take up this one. Then this is plus x3. Then this z1 minus z2. So using summation symbol, I will get this one x1 z2 z3. Okay. Here actually actual sign is minus, then it is z1 minus z3. I have taken minus common. This is minus minus will be plus, then x2 z3, so that I can use the summation symbol. Okay. Next, we know that if z equal to x1 plus I y1, then z conjugate will be my x1 minus I y1, so that x1 is my z plus z conjugate by 2. Okay, putting this value instead of this x1, in the next step I will get this is equal to 1 by 2i sum over z1 plus z2 z2 minus z3. Okay, z2 minus z3 instead of x1 I am putting this one. So in next step, as 2 is constant, 2 can be taken outside the summation symbol, so it is equal to 1 by 4i summation z1 plus z conjugate z1 conjugate by 2 z2 minus 2 is taken outside, so there will be no 2. This is z2 z3. In the next step, this is 2i. I am writing this, expanding this one. This one is z1 z2 minus z3 plus z1 conjugate z2 minus z3. Here this determinant is 0 because this is the determinant. Here this is the determinant of z1. Here z1. If I expand this, this is the z1. Z1, omit this row and this column z1 multiplied with x2 minus x3 will give us the value of determinant, but here z1 multiplied with the cofactor of the other element will give the value of determinant is 0. So this portion will be my 0. This portion is 0 because here the element is not multiplied with the cofactor of the corresponding cofactor, but it is multiplied with the cofactor of other element. So this determinant will be 0. So I have left with this one, that is 1 by 4 pi sum of z1 conjugate z2 minus z3. Okay. In the next step, in the next step 1 by 4 pi we have this z conjugate z2 z1 conjugate z2 minus z3. Okay, so here I'm multiplying by 1 z1 and dividing by 1 z1 so that our equation remains same, does not create any change. Multiplication by and division by same number will not create any change. So in the next step it will be, this is modulus of z1 square, this is z2 z minus z3 by z1. Now which is the required region. With that I would like to conclude. Thank you. Remaining will be in the next.